Hi, I'm Richard Gage, AIA, 30-year architect and member of the American Institute of Architects and founder of Architects and Engineers for 9/11 Truth. We're a nonprofit organization of now more than 3,000 architects and engineers signed on to the petition demanding a new investigation into the destruction of all three World Trade Center skyscrapers on 9/11. I'm joined today by civil engineer Roland Angle, director of our project due diligence outreach effort to the engineering community. Roland graduated from UC Berkeley and began his career by designing hardened missile silos to withstand nuclear bomb blasts. He went on to a broader career in the civil engineering and construction fields, spanning 50 years. Let's bring him in. Hi, Roland.
Hi, Richard. Glad to be here.
Awesome to have you. We're both very excited, in fact, to be here with you guys in order to announce the completion and final report of the 4-year computer modeling study of World Trade Center 7 performed by the University of Alaska at Fairbanks. Roland will be giving you highlights of the study that was led by Professor Leroy Hulsey and his team of PhD researchers at UAF. Professor Hulsey, the top forensic structural engineer of 50 years also, served as chairman of the Department of Environmental and Civil Engineering at the university. The UAF team has conducted a robust finite element analysis of the collapse of this 47-story skyscraper, the third to collapse on 9/11, which so many know nothing about. If you're among those, then you may be surprised to learn that this high-rise fell suddenly and unexpectedly at 5:20 in the afternoon, 7 hours after the Twin Towers destruction. Building 7 fell symmetrically at free fall acceleration in under 7 seconds, in the exact manner of a classic controlled demolition. Yet NIST, the National Institute of Standards and Technology, tasked by Congress to explain this collapse to the American people, claimed in their 1,000-page report, issued 7 years after the collapse, that the building fell due to normal office fires. But this has never happened to a steel-framed skyscraper before 9/11. So we've got some important learning to do today. First, though, I'd like to say a hearty thank you to the thousands of concerned citizens who we worked with to fund the university in order to complete this historically important work. Roland is here to give us all his insights into this important study and present its startling conclusions. Ready to go, Roland?
I'm ready.
All right, let's rock and roll.
Building 7 seen here on the day of 9/11 collapsed late in the afternoon. I want you to pay close attention to the penthouses on the top because they enter into the analysis in a very critical way. Since this is from the north, this is the east penthouse, and this is the west penthouse over here. There's a curtain wall between them. I just point that out now because we'll come back to that later. Professor Hulsey and his graduate students, Zili Kwan and Feng Zhao, agreed to do a structural reevaluation of the collapse of World Trade Center after we had approached the University of Alaska, and they conducted that study between 2015 and 2020. It was just released. The reason why we wanted to study this building is because there was a serious problem. The National Institute of Standards and Technology reported that the collapse of the building at 5:20 that day was due to normal office fires. However, no other steel frame high-rise had totally collapsed due to fire prior to that date or since. So it's essential for ensuring the public safety that the failure mechanism for this structure be thoroughly understood. So the university agreed to re-examine the collapse, and we provided the funding. The study had 3 objectives. First of all, examine the structural response to the fire loads. Second, rule out scenarios that could not cause the collapse. And third, identify the types of failures and their locations that could have caused the observed collapse. The material properties that were utilized were the same that NIST used, and we validated those. A36 steel, A572 steel, and 3,500 psi concrete. The methodology used three approaches: simulate the local structure response to fire loading on floors 13 and below where the fires were. The second approach, examine the collapse initiation hypothesis that was developed by NIST, as well as the collapse hypotheses advanced by private engineering firms whose studies were commissioned as part of litigation that was related to the collapse. And third, simulate several scenarios within the overall structural system to determine what type of local failures and their locations may have caused the total collapse to occur as it was observed. There were two official reports on the building failure. FEMA issued a report in May of 2002, which was a preliminary report that just reported on the evidence that had been found and suggested some possible avenues of investigation. NIST issued their report, as Richard mentioned, later in 2008. In addition to that, there were the privately funded reports for the, first of all, for the lawsuit. The Arup Group issued a report for the plaintiffs, which was Con Edison and their insurance company, in their lawsuit against World Trade Center properties, and their report was released with the publication of the Second Circuit Court of Appeals decision in December of 2013, ruling in favor of the defendants. The Weidlinger Associates performed a study for the defendants in the same lawsuit. However, this report was never entered into the court record and only became publicly available in June of 2016. However, the thermal analysis on which it was based has not been publicly released. Then there's our study, funded by AE 911 Truth, performed by the University of Alaska Fairbanks Department of Civil and Environmental Engineering, and that report was just released. The building was located about 350 feet north of World Trade Center 1. It was a 47-story high rise. Each floor was about 1 acre in area. Here again, we see it from the north. It was shaped like a trapezoid with the long side on the north side of the building and the short side on the south side of the building. That's important to remember. It was built over the Con Edison substation, a 2-story high building that they erected the building over. The foundation caissons, some of them went through the Con Edison substation, and some of them attached to the caissons that were already through the Con Edison substation. The floor plan of the building shows that there were 58 columns around the exterior, and there were 24 columns around the core, for a total of 82 columns. The columns that we're interested in are over here on the east side of the building, east side of the core, particularly column 79, 80, and 81. And the girders that frame into column 79 of particular interest. There's one coming in from the north, going out to column 44, one running to the west, running to column 76, and one running to the south, running to column 80. And there's 5 beams that frame into that girder coming in from the east. This is what it looks like. There's the girder, which they delineate as girder A2001, and these are the beams framing into it from the east. During construction, we can see the arrangement of the columns here, the perimeter columns, the girders that connect the perimeter columns, the framing between the perimeter girders, perimeter columns. The core columns are here, and they surround the area of the elevators and the stairwells. The core columns and the perimeter columns are connected by a steel deck, with concrete covering. 7 hours after the Twin Towers came down, the building, which wasn't hit by a plane, collapsed and turned into a 5-story pile of rubble in about 7 seconds. Notice again, this is from the south, so here's the east penthouse, the west penthouse. Now, in these series of videos, these videos were started after the west penthouse had fallen through the roof of the building. You see, when this video starts, the penthouse is already gone. So that's true in all the videos that we're going to watch here. So we'll see a longer video later that shows the entire process. But this shows the building coming down.
For the third time today, it's reminiscent of those pictures we've all seen too much on television before, when a building was deliberately destroyed by well-placed dynamite to knock it down.
Did they actually use the word brought down, and who was it that was telling you this?
The fire department, and they did use the word, we're going to have to bring it down.
We heard this sound that sounded like a clap of thunder. It looked like there was a shock wave ripping through the building, and the windows all busted out. About a second later, the bottom floor caves out. The building followed after that, and we saw the building crash down all the way to the ground.
And I turned in time to see what looked like a skyscraper implosion. Looked like it had been done by a demolition crew. The whole thing just collapsing down on itself.
It was almost as if it were a planned implosion. It just pancaked.
Since it was about 350 feet away from the North Tower, some of the debris from the North Tower hit it when the North Tower came down. Here we see the North Tower coming down that morning, and we see Building 7 over here. The light debris from Building 1, the North Tower, hit the southern face of the Building 7. And FEMA mapped that debris pattern here, and we can see that some of it did, in fact, impact the south wall of Building 7. NIST gave us a pictorial view of that damage as they interpreted it. There was damage in the lower southwest corner of the building and some damage to the upper floors on the middle of the south side. NIST stated that this debris damage had little effect on the initiating collapse. Some photos taken during that afternoon. Here's one at 2:11 of the east wall of Building 7, and here's one at 3 o'clock of the north wall. We can see the fires are active at that time. FEMA thought that maybe there was diesel fuel that was involved in the fires. There were some auxiliary generators for backup power on the 5th floor. These were louvers for that air intake, and there was no smoke coming out of that. So the conclusion was that the diesel fires had nothing to do with the collapse of the building, and most of the fuel was recovered underneath the building afterwards. NIST claims, and the evidence shows, that there were fires on the 7th, 8th, 9th, 11th, 12th, and 13th, 19th, 22nd, 29th, and 30th floors. However, the fires on the upper 4 floors were not active after 1:30 p.m. and were thought to have nothing to do with the collapse of the building. This is a view of the north face of the building, taken about 90 minutes before it collapsed. We can see that there are floors active on the 8th floor here, apparently working its way from the west to the east. And there were floors that had been active on the 8th floor, working in the same direction, apparently. Up on the 12th and the 13th floors, we can see that floors are still active. Here on this floor, the fire is working its way from the east to the west. And same thing, apparently, with the 13th floor. We can see that there's still some fires active around column 44, which is of interest to us. So it's important to remember as far as office fires goes that they depend upon office furnishings for their fuel, and they burn out areas in roughly 20 to 30 minutes because they run out of fuel. So they have to move. And we see that that's what's happening here. The NIST collapse initiation theory starts with the 13th floor and starts in the northwest corner of the building with these 5 beams that frame into this girder, A2001, that runs between column 79 and column 44. And they say that the thermal effects on those beams cause them to expand and contract later, and that either pushed or pulled this girder off of its seat and caused it to collapse. And that collapse on the 13th floor caused the girder to hit the next floor down, the 12th floor down, and that in turn caused a cascade of these beams in this area all the way down to the 5th floor, and that caused the column 79 to buckle because it was unsupported for such a long distance, and that in turn led to the buckling of 80 and 81, led to these 3 76 through 78 buckling, and the collapse proceeding from east to west of all the core columns, and then that resulted in the collapse of the perimeter columns, which led to the global collapse. So that's their theory. It's a progressive theory. In other words, one event, the expansion of the beams, led to another event, the pushing off the girder, led to another event, the falling of the floor, led to another event, the cascade of floors, led to another event, the buckling of column 79, and then the buckling of adjacent columns, and then the buckling of all the perimeter columns. A progression of events, an initiating event. We're going to look at that analysis. Their report said that the initial event was the girder, A2001, being pushed off of its seat at column 79. This is the drawing of column 79 and shows the beam, the girder seat, which was supported by a plate that was welded to column 79, being attached to the column. They said that that seat was 11.5 inches wide, only 11 inches wide. However, the bill of materials and later investigation showed it was 12 inches wide, which is a somewhat important fact considering that they're saying the girder was pushed off of that seat. So that's why that's important. Professor Halsey and his team titled their report a structural reevaluation of the collapse of World Trade Center 7. They used finite element models to recreate the structure so that they could test it under fire loads. This is their abacus model of the 12th and 13th floor. You see the perimeter columns, the core columns. This is column 79. This is the northeast corner of the building. So this is the area that we're concerned with. Now, one important thing to note is that when NIST modeled their floor, they assumed that this perimeter wall here on the east side was fixed and did not move as a result of the fires. Professor Halsey's team found that that was not true. When you take these 2 floors and you heat them up with the fires, what happens is there's some area around here that doesn't move, and everything else moves away from that. In other words, from here they're moving to the east, from here they're moving to the east, here they're moving to the west, here it's moving to the north, and here it's moving to the south. Now that assumption that NIST made and runs counter to the findings that Professor Halsey had. So that's an important fact to remember as we go on and investigate the differences. Here's the worst case floor temperatures that were used for the 12th floor. NIST shows these temperatures, which are color coded. You can see that their maximum temperature down here is about 675 centigrade, which is over 1300 degrees Fahrenheit. Then this is the floor framing underneath that concrete pad, and same thing for the 13th floor here. You can see that in both cases, the maximum temperature that NIST found was in the area of the eastern part of the building. So in approach 1, the UAF team looked at the structural response to the fire loading. The displacement of the 13th floor in the east-west direction is shown here. So the purple is the greatest displacement, and we see that that occurred on the east end of the building. So in other words, the UAF team found that this wall moved about 5 inches or more to the east. That's in contrast to NIST. Now, remember, they said that that whole perimeter wall remained fixed. When we look at the north-south direction, we see that the maximum north direction was about 3.5 inches in the UAF model, and that occurred up here in the northeast corner of the building. They used 2 different finite element models to mimic the behavior of the building. The SAP 2000 analysis showed that the X displacement, the X direction, that is in the east-west direction of the floor at column 79 was almost 2 inches, about 1.9 inches. And in the north-south direction, it was about 3/4 of an inch to the north. So in other words, they're saying that the floor displacement at the column 79 was about 2 inches to the east and about 3/4 of an inch to the north. Now, they also found that the westward displacement of the girder relative to column 79 was found to be less than 1 inch, which differs substantially from the 6 1/4 inches of westward movement found by NIST. All right, so that is largely due to the boundary conditions that NIST imposed, claiming that the east wall was fixed. The abacus analysis, which was used to check the SAP 2000 analysis, and so that we could compare and see if we're getting consistent results, showed that the X direction of the floor direction was 1.85 inches, and in the north direction was 0.94 directions. And that's very close to what the SAP 2000 results were. And it's found that the westward displacement of the girder relative to column 79 was 3.68 inches with no shear studs on the girders or the beams, 2.18 inches with shear studs on the beams only, and less than 1 inch with the shear studs on the beams and the girder, which was the actual condition. The reason why those other modalities were examined was because there were some claims by NIST and the other examiners that as to whether or not there were shear studs on the beams and on the girders, and that made a difference on how the structure reacted. The abacus analysis was checked against the NIST boundary conditions with no spatial restrictions, and found that the westward displacement of the girder relative to column 79 was 5.11 inches. So this was an attempt to replicate NIST's findings. But we found it was a full inch less than the 6.25 inches of westward relative displacement that NIST reported, and nearly an inch less than the 6 inches westward displacement, which would have been required to push the web of A2001 past its 12-inch seat at the column. So we were unable to replicate NIST results, probably due to the difference in input values and assumptions. Second approach was to evaluate NIST's collapse initiation policy hypothesis. So here we see the abacus analysis, column 79, column A2001, column 44, the 5 beams, and the 2 girders framing in from the west and from the south. Looking at column 79, we see that it had 2-inch thick side plates that were welded to the column at the 13th floor, and they protruded past the corners of the column by 1.8 inches on each corner. The abacus analysis of UAF showed that with the beams heated to 600 degrees Celsius, and the beam heated to 500 degrees Celsius, The beam would push the girder to the west, but the girder would elongate and be trapped behind the side plates. Somehow, NIST doesn't take those side plates into account. Although they showed them on some of their drawings, they don't explain how it got past the side plates. So that's the first problem. Second problem is that the girder, as shown in the NIST report, looks like this. Here's the web, here's the bottom flange, it's attached with some clips, and here's the seat underneath it supported by its plate. The problem with that drawing and that replication is that there was a 3/4 inch thick stiffener plate welded to both sides of the web, and you can see that here. Welded all the way around to the web and to the flange, the bottom flange. Well, that's going to make a big difference on how that girder is going to behave when it's pushed to the west, because the NIST analysis depends upon this flange folding up due to lack of stiffness when the web moves past the corner of the seat. However, putting those stiffeners in there makes a huge difference in the strength of that bottom flange, so the curling up wouldn't occur. We know that the stiffener was there because there are photographs taken during construction showing the stiffener welded to the girder. Here's a graphical representation: the girder, the column, the stiffener plates, the beam framing into the girder, the girder seat, and the plate that's welded to the column. The NIST analysis left the stiffeners off. So here we see their analysis: the beam, the girder, the column, and here we're looking at it with the column removed, and there's no stiffener plates on the girder. They admitted that they left the stiffeners off because they said that the web crippling, which they were designed to stop, didn't occur. So they didn't need to include the stiffeners in their models. Now that is an analysis that would not stand up in any engineering class, and I'm sure that that's why they had Michael Newman, a public affairs officer, sign that statement and not an engineer. We see here that in the abacus analysis, with the stiffeners included, even if you took away the side plate on the column, let the beam push the girder so that the web is well past the corner of the seat, that the flange doesn't fail. So that's the next problem that they had. Going further, if you allow the girder to fall, to see if the next step is going to occur, here the girder is allowed to fail, falls down, hits the 12th floor below, and it would hit the same girder on the 12th floor, A2001, near the column 79 on the 12th floor. You can quickly calculate how much force it would take to break that floor loose, and it would take 632,000 pounds of force to break that A2001 loose on the 12th floor. When you analyze that load, you find, first of all, that the frame is going to separate from the floor slab and operate independently, because supposedly all these shear studs have been broken and it's allowed to fall. It has a frequency of about half a hertz, and utilizing that information, you can put that information into this equation and find the stiffness of this system, which turns out to be about 550 pounds per inch. And then utilizing that, you can find the stiffness of the entire system, that is the floor falling and the floor beneath it, turns out to be almost the same because the floor below it is so stiff. And then you can use the potential energy at impact of about 3.5 million inch-pounds, which was found by the Arup group, and we verified that and put that into an equation and find the deflection of the frame system once it hits the lower floor. It turns out to be about 112 inches. And then using that, you can calculate the impact force, which turns out to be about 62,000 pounds, which is only about 10% of what you would need to break the wells loose at the girder support plate below. So this would indicate that the 12th floor below would not fall and the cascade couldn't happen. Now, it's important to note that the NIST report kind of begged its bets here and said that, well, maybe it wasn't the floor below, that it wasn't the girder below that fell. Maybe the other girders were knocked loose. In other words, the south girder coming into the column or the west girder coming in the column. They even had a scenario where the south girder coming into the column broke loose at the 14th floor, but they don't provide any information to explain how those connections failed. And without an explanation, those scenarios are not credible. So approach 3, the simulation of the global collapse was undertaken, and here we see the actual footage with the east penthouse falling through the roof first. So we're going to watch that sequence now. We'll get to see the whole thing. About 7 seconds before the building comes down, the east penthouse goes through the roof. There. Time goes by. The west wall begins to collapse. Then the west penthouse goes down. Then the building starts to collapse. Okay, so there's a sequence there. This occurs first. There's about 7 seconds between the time that goes through the roof and the time the building starts to fall. One more time, look at the windows and the distortion of the building. You see some window breakage underneath the east penthouse, very little distortion of the facade, and the building drops pretty much straight down. Now we'll compare that to the NIST simulation. On the right, you'll see their simulation starts with the collapse of these floors down here in the northeast corner of the building, low down at the 13th floor, and watch how that affects the east penthouse up above. That's very important. There's the collapse. The east penthouse falls through, then the west penthouse, and then the building starts to collapse. However, the NIST simulation doesn't go any further than that. So it's suspect because the building has already started to deform significantly on the exterior, on both the west side and the east side, upper and lower. In their report, they show what the view from the west would look like into the collapse and from the south, and you can see that the distortion of their building is considerable in their model. So that doesn't match the observed collapse. So it can't be used as a model to explain the collapse if it can't match the collapse. In the UAF study, they looked at the question of the east penthouse collapsing. How do we get the east penthouse to collapse up here when the initiation of the event occurred down here? Remember that there are 3 girders connecting into those into column 79 all the way up to the 47th floor. So that's like 102 girder connections between the 13th floor and the 47th floor that are tied in to that column that would prevent its falling and causing the east penthouse to fall. The east penthouse was over that column. So they found that indeed, if you collapsed it here, the east penthouse was not affected. You had to collapse those columns way up here in the top 3 or 4 floors in order to get that east penthouse to collapse through the roof. So that is a major sticking point with the NIST analysis. How do they get that penthouse to collapse when they were collapsing the floors way down low in the building. UAF analysis said that could not happen. Then we'll look at their horizontal core column failure scenario. They said that when these three columns fail, first 79, then 80, then 81, that would lead to a collapse of the next three columns, 76, 77, and 78. And that would in turn set off a progressive collapse across the core columns, which would then lead to the collapse of the exterior columns. What there, where the UAF analysis found that when you take out those six columns, 79 through 81 and 76 through 78, what happens is that these columns here in the southwest corner of the building are overloaded and fail. And when they fail, that leads to further column then of some more of the east columns, one column over here on the west side, then the other core columns start to fail, and some of them even on the north side begin to fail. So they don't find the same sequence. When you look at how that would appear, the building would tip to the southeast after the typical failure, hypothetical failure of 76 to 81. So this analysis shows that the failure would not look like the failure that was actually occurred. It would look like this. Sorry here. Here we go. Notice that the east penthouse is still intact. The building falls over to the southeast. So even if you gave NIST their collapse initiation hypothesis of the girder falling off and the floors collapsing and the column collapsing, you don't get a scenario that looks like the building when it actually collapsed. The building would fall over to the southeast. The UAF global collapse analysis said you had to simulate the simultaneous failure of all the core columns over 8 stories, followed by 1.3 seconds later by the simultaneous failure of all the exterior columns over those same 8 stories to produce exactly the behavior observed in the videos of the collapse. Now the east penthouse has to collapse through the roof 7 seconds later, and then global collapse ensues. So what you have to have is you have to have a separate event up here. These columns 79 through 81, which supported the east penthouse, have to collapse up here first, and then the global collapse down low of all the core columns, and then the perimeter columns 1.3 seconds later. If you do that, you can get the collapse the way it looked in the event. So let's do that. There goes the east penthouse. These columns underneath it failed. Then the core columns down low fail, and then the perimeter columns fail, and the whole thing drops. One more time. East penthouse, and the west penthouse when the core columns collapse, and then the entire building coming down. So that was the only way that UAF could get the to replicate the appearance that the actual event showed us. Here you see it from another view. East penthouse, west penthouse, and then the building. Long gap between the east penthouse, 7 seconds, and the rest of it. So the next question that we addressed was free fall acceleration, because physics teacher David Chandler proved that the entire roof line of the building was in full free fall acceleration for about 2.5 seconds, which is how long it would take to fall 8 stories. NIST was confronted with this fact in their preliminary draft report in August of 2008. and they were forced to admit in the final report that it did fall for 2.5 seconds, but they never addressed the implications of free fall, or they didn't change their model or their conclusion. Now, here Chandler graphed the velocity versus time, and he found that about 3/4 of a second into the collapse, it went into free fall. The slope of this line is free fall for about 2.5 seconds before it started to encounter resistance on the way down. He's going to explain that.
Just by watching it, anybody can see that Building 7 fell close to free fall. To measure it, I used software to track the corner of the building and compute a graph of downward velocity as a function of time. The graph had a long, straight section indicating constant acceleration. Measuring the slope, I found the acceleration to be within 1% of the acceleration of gravity for the first 2.5 seconds. In other words, the building fell through its own structure with zero resistance. Just by watching it, anybody can see that Building 7 fell close to free fall.
Okay, now the problem with that is that according to the NIST analysis, the columns were buckling, and that's what caused the building to fall. But when columns buckle, they still retain some of their resistance to vertical motion. So this graph here shows the relationship between the deflection, vertical deflection, and the yield strength, the load, and it only declines to about 1/3 of what it normally could hold. So since there's always some resistance, the free fall could never be occurred. It would always have some resistance. In free fall, all the potential energy is converted to kinetic energy, and it can't be doing any other work. So if you take out 8 stories and they buckle, you couldn't get free fall. You have to take them out completely. The NIST theory doesn't account for that. So the conclusions of the analysis are that, the UF analysis, are that columns 79, 80, and 81 did not fail at the lower floors in the building. In order to cause the east penthouse to fail first while not generating any significant deformation of the exterior, those columns had to have failed only at the upper part of the building. But there were no documented fires above the 30th floor. Secondly, the hypothetical failure of columns 79, 80, and 81, the 3 easternmost core columns, would not trigger a horizontal progression of core column failures. So the hypothesis of NIST, Arup, and Weidlinger that the buckling of column 79 would trigger a progressive collapse of the entire building are invalid. The collapse of column 79, 80, and 81 high in the building would have to have been a separate and distinct event from the global collapse occurring first. Third, even if we assume the failures of columns 79, 80, and 81 could lead to the failure of the next row of core columns, the additional hypothetical failure of those 3 columns would then overload the exterior columns around the southeast corner of the building rather than overloading the next row of core columns to the west, and that would result in the building tipping to the southeast and not in a straight down collapse. Next, the simultaneous failure of all core columns over 8 stories, followed 1.3 seconds later by the simultaneous failure of all exterior columns over the same 8 stories, produces almost exactly the behavior observed in videos of the collapse. The collapse could have started on any of the various floors starting at the 16th floor and below and produced the same behavior. The conclusions are that the collapse of World Trade Center was a global failure, not a progressive failure. It involved near simultaneous failure of all columns in the building over an 8-story span, and not a progressive collapse involving sequential failures of columns throughout the building. Despite simulating a number of hypothetical scenarios, the UAF team was unable to identify any progressive sequence of failures that could have taken place on September 11th and caused a total collapse of the building, let alone the observed straight down collapse with approximately 2.5 seconds of free fall and minimal differential movement of the exterior. Please share this information with your fellow engineers. You can download the report at ine.uaf.edu/WTC7 and sign our petition calling for a new investigation at our website, ae911truth.org. Thank you for your attention today.
Wow, Roland, that was a lot of powerful information. Let's digest this for a minute. I mean, I was particularly impressed in this study by the effort that Professor Halsey and his team of PhD researchers finally arrived at, after disproving that this building could have come down by fire. They say, well, how could it have come down? They had to remove 80 columns on at least 8 floors all at once in an instant, followed a second later by the exterior columns. I mean, really, what can do this? This, of course, only controlled demolition can accomplish that. So I want to encourage people for more answers on this critical question to look at our landmark documentary, 9/11 Explosive Evidence, Experts Speak Out. It's free on YouTube. Just search 9/11 Experts Speak Out. It comes right up. In it, we've assembled 40 high-rise architects, structural engineers, metallurgists, chemists, physicists, controlled demolition experts, all laying out the evidence about the controlled demolition of this 47-story skyscraper on 9/11. So if you guys are hearing about this subject for the first time, I hope that you found today's webinar enlightening. And in this short period of time that we've been able to explain adequately some of these scientific concepts involved, you can read the report yourself. It's short of 130 pages. Download it at ae911truth.org or at the university website, ine.uaf.edu/WTC7. And take the time to understand the differences between the Halsey report and the NIST report and draw your own conclusions as to which better explains the collapse that you've now seen in the videos, because the ramifications of the NIST report being exposed here basically as fraudulent by the University of Alaska. They won't make that claim, but it becomes rather obvious. This is not just about a building. This is about all of 9/11 and what really happened there. If Building 7 raises these kinds of questions, being obviously a controlled demolition, especially once you've seen the scientific forensic evidence and the eyewitness testimony in the documentary we've mentioned and in our other works, including our webinars, which are called 9/11, An Architect's Guide, a 3-part series. You need to look at the Twin Towers also. And there are all kinds of questions that are raised there. So we encourage you to take a look at the rest of the questions. So you can also submit your own questions to Roland and myself by visiting ae911truth.org and clicking the Contact Us form. And if you're so moved by the information that we're presenting, please sign our petition. If you're a structural engineer or an architect or any kind of an engineer and architect, we have 3,000 architects and engineers signed on to the petition demanding a new investigation. You can support them as well. We have 20,000 others calling for a new investigation. So everybody can sign the petition. And help us, therefore, then to bring the report to the engineering community, to Congress, to the media. We have all kinds of opportunities to do just that. The more engineers that we have raising our voices, the more Congress will listen and eventually be forced to open a real investigation. Also, we're submitting a request for correction to NIST under the Data Quality Act, which will be based upon the findings in this report. NIST will be forced to correct their fraudulent, let's call it a deeply flawed report. If you're a structural engineer, we highly encourage you to sign on to the request for correction now, or a licensed architect, by emailing us at rfc@ae911truth.org. And even if you're not listening live to this, but on the archive video, you can still amend your name to the list of concerned structural engineers and architects signed on to this important document. Again, email us at rfc, request for correction, at ae911truth.org. A special thanks to you, Roland, for the insightful presentation tonight.
Thanks, Richard. It was my pleasure, and I would like to add a note to the engineering community that this is a matter of supreme importance for our profession. Please educate yourself about this matter and join us in calling for a new investigation. Thanks.
Absolutely. And thumbs up also to Professor Halsey and the great team of PhD researchers at the University of Alaska in Fairbanks. We're proud to have supported the university in performing this truly scientific and historic study. And thanks everyone for joining us today. Bye for now.
Bye-bye.